Welcome my students and viewers. In previous classes, I have explained correlation and regression analysis in quite detail, just covering all the topics of this. Of course, right now I am dealing with simple correlation and simple regression. Thereafter, I will treat multiple correlation as well as the multiple correlation. Right now, until now, I am in simple correlation and simple regression. So, as I have finished these two chapters, so today and for another 1 or 2 days, I shall be just posting MCQs based on this correlation and regression analysis. जब आप इस पर काम कर लेते हैं उसके बाद फिर इस पर देखना पड़ता है क्वेश्चंस, और जैसे कि नेट गेट सब में क्वेश्चंस आ रहे हैं तो वो सभी सब होते हैं, आपसे MCQs होते हैं. So today I am just dealing with few questions on correlation analysis, and next video I shall be posting on few questions on the linear regression analysis. So let us start, and today it is 6 questions written right over here. First question is, if Rxy is 0.38 and covariance xy is 10.2, variance of x is sigma square x is given as 16, then we have to find out standard deviation of y, that is sigma y. Now, we know that R is the covariance xy divided by sigma x, sigma y, standard deviation of x, standard deviation of y. Now, everything is given and whatever is not given has to be calculated. R is 0.38, covariance is 10.2 divided by variance of x is 16, so standard deviation of x would be 4 and into sigma y. Now, this equality has to be solved. Cross multiplication with this one. So 1.52 sigma y stands as 10.2. So sigma y is 10.2 by 1.52 and is 6.7. So answer would be, the standard deviation of I would be 6.7. Next question. If covariance between height and weight of 5 items is 6 and their standard deviations are, standard deviation of height is 2.45 and the standard deviation of weight is 2.6, we have to calculate Rxy. So R would be defined as covariance between height and weight, and this divided by standard deviation of height and the standard deviation of weight. We shall substitute all the values. Covariance is given as 6. So 6 upon these two are the standard deviations. When this is calculated, we get R as 0.94. Number 3, if Rxy is 0.4, covariance xy is 10, variance of x is 9, then find second moment about mean. One thing has to be understood right here, that second moment about mean happens to be the variance. Second moment around mean or about mean is the variance, and so here we have to calculate variance of variance of y. So from our formula, we shall get the standard deviation of y, and by getting it squared, we shall get the second moment about mean of y. So Rxy is given as this 0.4, covariance xy is 10, and variance of x is 9. So obviously, standard deviation of x would be 3. So now let us put all the values. Rxy is 0.4, covariance is 10, and the standard deviation of x is 3. So first of all, we just must calculate standard deviation of y. So R equals covariance xy by sigma x, sigma y. We substitute all the values. R is 0.4 equals covariance xy is 10, sigma x is 3, sigma y has to be calculated. So from this equality, sigma y would be 10 upon 1.2, that is 1.3. This is the standard deviation of y. Now, in question it has been asked that what is the second moment about mean of y series, and this is variance of y, sigma square y. Right now we have got the value of sigma y 8.6. Simply it has to be squared up, and so second moment about mean of y or the variance of y would be 69.39. So this would be the answer. Number 4, given Rxy 0.5, find correlation between 2x minus 4 and 3 minus 2i. Yes, here one thing has to be explained, that when the very correlation coefficient, this correlation coefficient is 0.5, R is 0.5, absolutely it is 0.5, so X and Y either both has to be positive or both has to be negative. If both variables are positive or both variables are negative, R would stand as 0.5. Now in this question, X is positive and Y is negative. So definitely R would be minus 0.5. Just by observing these two equations, we can guess that R would be 0.5 because X and Y move in the opposite directions. Here, if both are positive or both are negative, then X and Y will move in the same directions. That's why R happens to be 0.5. But here it is quite obvious that X is positive, Y is negative. So X and Y is going to move in the just reverse directions. So R would be minus 0.5 instead of 0.5. Number 5. If U is 2x plus 1 and V is 3y plus 7, if Rxy is 0.8, find RUV. This is based on one of the properties of correlation coefficient, that R is independent of change of origin and scale. In this particular sum, only origin had been changed. Only origin had been changed because U is 2x plus 11. So this is the change of origin. Absolutely Y. V is 3y plus 7. So the origin of X and Y has been changed. Of course, the scale has not been changed. So since R is independent of the change of origin, so there would be no change in Rxy. Rxy would stand as 0.8. So Rxy is 0.8, then definitely RUV would also be 0.8 because X and Y, or the R is independent of the change of origin. So that is why RUV would also be 0.8. Number 6. Sample R is significant if R equals twice of probable error, R is greater than thrice of probable error, R is greater than 6 times of probable error, and fourth is R equals 4 times of probable error. In this context, you have to understand that what is probable error. Probable error gives us the reliability of R, of course sample R, keep it in mind. From sample, whatever we get R, then how far it is reliable or how far it could be used in further mathematical algebraic expressions and explanations, this depends upon the comparison between R and probable error. The probable error of R is 0.6745 into a standard error of R. This is the formula of probable error of R, and 0.6745 into 1 minus R square divided by root n. This is the formula of probable error of R. Now, when it is significant or insignificant, then this R would be significant if R, sample R, happens to be 6 times of probable error. Only then sample R stands as significant, else it will be insignificant. So if R is greater than 6 times of the probable error, we conclude that sample R is significant. This means that in the population, and population R is denoted by rho, rho is definitely not 0. So this is how we just find out the significance of R, and when R is compared with this probable error, we get whether it is significant or insignificant. So R becomes significant if it is greater than 6 times of probable error. So this would be the answer. This would be the answer. Let me explain a few more questions. This is 7th question. Here we have to identify which statement is true or false. Number 1 is, it says that positive Rxy implies that x decreases, y increases. Absolutely false statement. If Rxy is positive, both variables would move in the same direction. Either they will increase together or they will decrease together. So this is a false statement. Number B, R is independent of change of origin but dependent on the units of measurement. Absolutely, it is a wrong statement. When Carl Pearson was defining R, virtually what he wanted to express could have been explained by covariance xy. But if Rxy would be covariance xy, then definitely we shall have the units of measurement of x and y. Unit of measurement of x and y. If R would have been covariance xy. So to get rid of this problem, because any statistical measure does not have any units of measurement anywhere in statistics, all statistical concepts are always free from any units of measurement. So to make it free from units of measurement, Carl Pearson was forced to define R as sigma x and sigma y. Now, the unit of measurement of x in the numerator would be cancelled by the same unit in the denominator, and equally it will happen with a y. So when R is defined like this, it is absolutely free from units of measurement. Here says that it is independent of the units of measurement, so it is a false statement. And third is, R between x and y is 1.25. Absolutely impossible. That limit of R is, it is always greater than -1 and it is always smaller than +1. So R could never be smaller than -1 and R could never be greater than +1, and here it says that Rxy is 0.25. It is impossible statement. In question number 8, R is given as 0.8. Regression coefficient of y on x is -1.6 and regression coefficient of x on y is -0.4. Sigma y, standard deviation of y is 5, standard deviation of x is 2.5. So here it had been asked that find this standard error of x on y and y on x. So here we shall have to use both the formulas for SE of x on y and standard error of y on x. Now if R is 0.8, R square is 0.64. So standard error of x on y would be standard deviation of x into under root 1 minus R square. This is the formula. So standard deviation of x is given as 2.5 and into under root 1 minus 0.64. This becomes 0.6. So under root 0.6 and this 2.5 into 0.6, so it becomes 1.5. Now, standard error of y on x, formula is standard deviation of y into under root 1 minus R square. So standard deviation of y is already given as 5, so 5 into this has come out to be 0.6, so it is 3. This is how we just calculate the standard error of x on y or y on x. This is how we. So this formula has to be memorized. This one. This formula would be used for finding a standard error of the estimates. This says that the two lines of regressions are 2x, 8 minus 3y, 2y, 5 minus 6. We have to calculate Rxy. Right. For calculating Rxy, we should have the regression coefficient of y on x and x on y. So these two regression equations needs to be arranged a little bit. So this is x on y and it is given as 2x equals 8 minus 3y. So x becomes 8 by 2 minus 3 by 2y. Hence bxy is minus 3 by 2. Now second regression equation is 2y is 5 minus x, hence y is 5 by 2 minus x by 2, so byx is minus half. We have got these two regression coefficients, and with the help of these two regression coefficients, R would be defined as plus minus under root byx into bxy plus minus 3 by 2 into 1 by 2. So this is plus minus 3 by 4. It is plus minus 0.75 and it comes out to be 0.8. Probably it would be around 0.85. If it is 0.85, now we have to express the value of R. Now here we have to observe what was the sign of these two regression coefficients. Both of the regression coefficients happen to be negative, so R has to be negative, so R would be minus 0.85. If these two regression coefficients would have been plus positive, then R would have been plus 0.85. Since these two are the negative, so R would be expressed as minus 0.85. In the previous class, I had told that the algebraic signs of both regression coefficients and R, the signs of these three are always identical. So if these two are negative, R has to be negative. So students, I have solved 8-9 sums in today's class. In next video, I'll again post a few more sums on regression analysis. But for today's, this is all. Thanks and best of luck to my students.